you into the idea and into the process of learning from these videos. The topic today is powers, exponents, and square roots, which should be a review for everybody. It's something that you've learned last year, maybe even before that, depending on who your teacher was. But we wanted to kind of spend this week reviewing some of the things that you were supposed to learn last year and let you, again, kind of ease into this idea of videos and practice with topics that you already know a little bit about. So powers, exponents, square roots. You've got definitions there across the top that you should have already copied down in your notes from yesterday. So square, squared, cubed, perfect square, square root, and root 36. That should all be in your notes already. You should have those defined and ready to go. So just to jump into this, I try to keep these videos short. I don't like you to spend more time than you need to. And the nice thing about the videos is rather than me having to repeat myself 3 or 4 times, if you don't understand something, you can rewind and watch it again. Rather than having to raise your hand and ask me to say it again. So in these videos, I don't always succeed, but I try to keep them short. I try to only cover things once and not repeat myself a lot. Because if you don't need to hear it a second time, great. If you do need to hear it a second time, you've got a rewind button and you can watch it 2, 3, 4, 5 times if you need to until you understand what it is that we're trying to do here. So just a quick review of power, exponents, and square roots. First of all, when we're talking about powers, this is the kind of thing that we're talking about. You've got a number down here. It's usually, we call it the base, is the official name for it. So this number down here, the big number, is called the base. And this number up here that's smaller and kind of raised up above it is our exponent. So we have a base and we have an exponent. And what that means is a few different things. What your teachers have told you in the past, and we're going to actually add a definition right here, because you've been taught something very incorrect. And all through school, through college, you're going to keep repeating this incorrectly if we don't fix it now. So what I'm going to have you do is write down 2 definitions. The first one is incorrect. I'm going to have you write it down anyway because I want you to physically scratch it off. I want you to cross it out. I want you to remember that that is wrong. So the definition that we're going to write down and that we're going to add right here is the definition for exponent. Okay? Now what you've been taught in the past is that the exponent, this number right here, you've been taught that this number tells you how many times you multiply the base by itself, meaning how many times do I multiply 4 times 4 times 4? So let's write that down. An exponent is how many times you multiply the base by itself. That's what you've learned in the past. So pause the video, write that down. How many times you multiply the base by itself? Now here's my problem with that definition, and here's the reason we're going to cross that out. Okay? So 4 to the third, that means 4 3 times. So if I were to write that right here, what that means is 4 times 4 times 4. I've got 3 4s, but I'm only multiplying twice. So how many times you multiply the base by itself? I didn't multiply the base 3 times. I only multiplied the base twice. And that's my problem with this definition. So what I want you to do is cross it out. An exponent does not tell you how many times to multiply the base by itself. An exponent tells you how many factors or multiples of the base you have. I have 3 factors of 4. I don't multiply 3 times. I only multiply twice. 4 times 4, that's once, times 4, that's twice. So I have 3 factors or 3 multiples of 4. So 4 to the third means 4 times 4 times 4. I've got 3 4s. If I were to say 5 to the 5th power, that equals 5 times 5 times 5 times 5. I've got 1, 2, 3, 4. I need one more 5. I've got 5 5s. I'm not multiplying 5 times. I've got 5 5s that I multiply together. So this definition is one I really want you to think about. It's one that I'm going to ask you and test you on and hope that you remember. It's how many factors or multiples of the base we have. So 4 to the third, 4 times 4 times 4, 5 to the fifth, 5 times 5 times 5 times 5 times 5. This year, you get the benefits of using a calculator for most of what you do. So the way that you do this on the calculator, if you have 4 times 4 times 4 or 4 to the third, the way that you're going to do that on the calculator, make sure I put this up here where you can see it. So in order to do a power or exponent, you're going to use, it's called the caret key. It's this key right here. We call it a caret, I guess because it kind of looks like a carrot. So what I would do is put 4, my base, and then the caret key. And if you look at the picture, it moves my little cursor up and makes it small. So when I put in that 3 and push the arrow over, it looks like my paper. 4 to the third, it looks the same. And when I hit enter, it's going to tell me that it's 64. Okay? Doing the square root. Now, square roots are kind of like doing exponents, but backwards. This is saying 4 to the third equals something. The square root is when we're working backwards. So if I wanted the square root of a number, so for instance, let's say, let's pick an easy one. Let's say that I want the square root of 100. What that is saying is what number times itself equals 100. One way to look at 4 to the third or 4 squared, and we can even write this down right here. 4 squared, one way to look at that is that you have a square with the sides of 4. And we know that 4 squared, 4 times 4 is 16, which happens to be the area of that square. Okay, now if we do 4 cubed, that means that I have a cube, and it's 4 by 4 by 4. And when you multiply all of that together, 4 times 4 is 16, times 4 again becomes 64. So that would be the volume of that cube. Now, square root's going backwards. We already have the square. We know that the square is 100 on the inside of the square, just like the 100's on the inside of the square root. What we want to know is what are the sides of the square. If the inside is 100, what are the sides? The easiest way to do that is right here on your calculator. You hit the second, and then this button right here that has an X and a square on it. You do the second squared, and it'll pop up a little square root with a blinking light underneath, and I plug in 100. Push my arrow over so that I'm on the outside, and when I hit enter, that tells me that the sides of my square are 100. The inside of my square is 100, The sides of my square are 10. So square root of 100 would be 10. Okay? And we can add that right here on our notes. So to do the square root, you're going to hit the second button, and then you're going to hit the X squared key. And you can see the little square root picture right there above the X squared in the green. All right? So that's kind of the sum of squares, exponents. That's really the most I need you to know about it this year. We're not going to get too much more in depth than that. There is one other thing that I want to talk to you about, and that are special exponents. And a few of those we're going to we're adding some notes here. Hopefully you're writing all this information down as I write it down, stuff for you to refer to. But a few special exponents that I want you to keep in mind, okay? Any number, if I take x, which can be any number I want, and I raise it to the power of 1, if my exponent is 1, my answer is always going to be x. Because if when we look at our definition, how many factors or multiples of the base? X to the 1 means that there's only one x. So there it is. There's only one x. Okay? Now, x to the 0, we have to be really careful of, because a lot of people think that any number raised to the 0 is 0, but it's not. Any number raised to the 0 power is actually 1. And this is something that I promise you will see on the test. It's something that you will see on the SAGE at the end of the year. It's something that you're going to see on any standard test that you take. When you get up to high school, you're going to see this a lot. A number raised to the 0 is going to be 1. And that's a big one for you to remember. So 5 to the first power is 5, but 5 to the 0 is 1. And what's kind of cool about that is 100 to the 0 is also 1. Or 1.007892 raised to the 0 power is 1. It doesn't matter what the number is, even if it was a fraction. Let's say 175 thirds raised to the 0. That is still going to be 1. Any number with an exponent of 0 is 1. And I'll show you why at the end of class, kind of in person. We'll talk about that a little bit. But I just want you to have that in your notes, and I need you to remember it. So box it, star it, make sure that you have that written down somewhere nice and big so that you remember. An exponent of 0 equals 1. And I know I'm repeating myself, and I'm repeating myself for a reason, okay? Remember, 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 remember this one. All right, so down here at the bottom, you've got 2 boxes. And this is kind of standard for what you'll see on our videos and our notes. On the left, it says together. I'm going to do these problems with you right now. And then when I'm done, you're going to do these problems on your own. This is what you're going to come and show me so I can make sure you understand the video. Once you show me these problems and that you've done them correctly, I'll give you the practice for the day. You can buzz through that, get it done, and make it on your way. All right, so together, number 1 right here, square root of 144. I'm just going to plug that in my calculator. You might be able to do that in your head. A number times itself equals 144. Let's plug that in the calculator for those of you that don't know how to do it. So second square root, 144. I make it look just like the picture, and when I hit enter, I get a 12. So what that means is the inside of the square is 144, which means the edges of my square are 12. 12 times 12 is 144. All right? Moving on to number 2, 8 to the 4th power. Again, I'm going to do my calculator. 8. Now I'm raising it to an exponent, so I'm going to do my caret and then a 4. 8 to the 4th power. And when I hit enter, I get 4,096. So 8 times 8 times 8 times 8 equals 4,096. Another way that we could have written that, and something that you may see that we didn't really talk about officially, is remember 8 to the 4th, that also can be written as 8 times 8 times 8 times 8. This right here we call expanded form, because we expanded it out. Exponential form is when it's written with an exponent. Expanded form is when we expand it out. Okay. Number 3, square root of 1,521. Again, I'm going to use my calculator. Square root, second, the square button, 1521. 1,521. Enter. 39. Okay. Most of your problems are going to be like this today. The calculator is going to do most of your thinking for you. 9 to the 5th power. That's not something I want to do in my head, so I'm going to put 9, raise it with my caret button to the 5th power, and hit enter. 59,049. 59,049. Okay? It's always a good idea to make sure that your picture looks the same. 9 to the 5th, that looks like my picture right here. That's one thing I like about these calculators, is it looks like it looks on your paper when you type it in, so you can make sure you do it correctly. All right. Number 5, use the given base to write each number in exponential form. So exponential form, remember, is when we have a number with an exponent. So we have a base of 5, and we're looking for this. We're looking for the exponent so that it equals 25.